The following video you're about to watch is the first video of a series of videos I started making to document my process while I become a software developer. The whole idea is just to go through certain problems and try to solve them while I speak to the camera, while I speak to you on the other side. And the idea is that it's going to help me improve for an interview setting, and it's going to help me also look back to these videos and see how much I got better, right? And I hope you can find something of value in it. I hope you can see the progress I'm making. If you're in the same track, jump with me and we'll learn things together. I hope to see you in the next videos. Stick with me. See you soon. Alright, I'm going to try to solve this problem for today. The idea is that I can track the problems I'm going to be solving to become a software engineer. I have somewhere around 2 years doing this. Not consistently, I have to say, because I've been getting in and out, in and out, in and out. I've been studying for a while now, but I haven't been consistently solving these problems. But let's go ahead and jump into the problem right here. Maybe I can put this somewhere. Well, right now we don't need this. So that's good. That's good. I hope the audio is good and everything's good. Anyways, we have this problem that says, given an array of integers, calculate the ratios of its elements that are positive, negative, and 0. Print the decimal value of each fraction on a new line with 6 places after the decimal. This challenge introduces precision problems. The test cases are scaled to 6 decimal places, though answers with absolute error are up to 10 minus 4 to the power of minus 4 are acceptable. So we have an array 1, 1, 0, minus 1, minus 1. There are 5 elements in the array, and 2 positive, 2 negative, and 1 0. The ratios are 2 over 5, 0.4 with 6 decimal places, 2.2 over 5, 0.4, and 1 over 5, 0.2. Okay. I see here, so 2 positive numbers out of 5, that's the ratio if you divide 2 over 5. Then we add the 6 decimal ratios, decimal places. 1 0, so 1 over 5, and 1 minus 1, okay? Complete the function in the editor, plus minus the following parameters. So we're going to get an array of integers. So it's going to be a single input array of integers, and obviously we have positive and negative numbers. We have to print the ratios of positive, negative, and zeros. One separate line, 6 digits. So the function should not return any value. So there's no return in this function, so we're just going to print our results. Okay. The first line contains an integer n. Okay, that's for the input. Second line contains n space separated constraints. So 0, it's going to be less than n. That n is going to be less or equal to 100. So these are going to be the numbers in the array. So the numbers are going to be basically from 0 to 100. Positive, negative, going both sides of 0, so to speak. Minus 100. All the way to 100. So That's also that's also the size of the array. So the array could be from 0 to 100. The numbers could be from -100 to 100. Okay. Output, we know that we're going to print the portions of each one's. Now, in this example, we got an array of, we have 6 numbers, we have 2 negative, we have 3 positive, and 1 0. So we can already see by simple interaction that the 3 positive over 6, we're talking about 1 over 5, which is 0.5. Then we go to 2 over 6, which is going to be 33, or 0.33, and then obviously 0.1. So 3 positive, 2 negative. Okay. I understand the problem. Right off the bat, it took me 5 minutes, somewhere around 5 minutes to read all that and understand the problem. So I thought about an approach already, which is obviously, or not obviously. I mean, nothing is obvious in this thing. And obviously, I don't know who's watching this, so you'll probably be like, "Oh yeah, I already got it." Well, I don't, but I'm working for it. So let's see. I like to open my little note-taking app, Excalibur. Hopefully, I can record that in this screen too, right here. Hopefully, we are able to see this screen over here too. But if you're not, it's really not important. Like, I'm literally just drawing here now. Gonna do just simplify the thinking process. So we are talking about, we have, let's put my mouse over here. We have an array. So we're gonna have an array of different elements. So let's say we're gonna have 1, 1, 0, -1, -2. Simple example. So we have to determine, we have 5 elements. We have to determine how many of these elements are positive. So we can go by establishing like a simple in an iterative way, or iterative way. Here we go. In an iterative way, we can say that for every item in this array, if the item is greater than 1, greater or equal to 1, because we're gonna care about zeros too. So if the item is greater or equal than 1, then the item is positive. So we add a count. We can have a count of positive, negatives, and zeros. So we're talking about, we create 3 different counters. And based on that count, then we divide that by the length of the array. So this array is length. This array is length 5. So length 5. So numbers greater than, these are conditions. Numbers greater than 1 are positive. Numbers, in order equals to 0 are 0, and numbers less or equal to -1, or less than 0 actually, we could say we could probably here say greater than 0, right? But we don't want to use 0 as a. We don't have to divide by 0, obviously. So I have a problem with the obviously. I think it tries to makes me sound smart when I really don't know this shit. Sometimes, or most of the time. Gotta keep it real. All right. So it's greater than 1. I would say greater than 0. We'll try like that first. We're gonna say, if the item is greater than 0, then it's gonna be a positive value. So these are our conditionals, right? So if it's greater than 0, it's gonna be positive. If it's equal to 0, obviously it is 0. And if it's less than 0, then it's negative. So we are going to say, these are our conditionals, and we're going to iterate and have counters. So in this case, we're going to say, greater than 0, we have 1 and 2. So we have two numbers. Equal to 0, we have 1. And less than 0, we have 2. So at the end, we divide this number by the length of the list. And that's how we get our fractions. These are the portions. So, 2 over 5, it's going to be equal to 0.30. 2 over 5, we had it over here, 0.4. So we have 0.4. I don't think we are in the hard part of the problem yet, because the problem always established that this is precision problem. So I think in Python, when we're talking about floating points, it's very hard to find precision, probably in most programming languages. But I know in Python it's very particular, due to the lack of flexibility sometimes, in the sense of we don't have more flexibility with data structures. Like in the case of integers, we have long integers in languages like Java or C++ or Swift. I'm experimenting with Swift. I'm liking Swift so far for iOS development. But yeah, so Python, I think that's going to be the problem, trying to find that. But we'll see. So 1 over 5, it's going to be 0.1. 2 over 5, again, it's going to be 0.4. So 2 over 5, it's 0.2. Thank you. I'm trying to breeze through this, and making silly mistakes. So yeah, 1 over 5 is 0.2, and then we're going to say the 2, 0.4 again. Okay. So then we have to print these values with 6 decimal places. So we are going to find that out. So let's try our logic first and see if that works. And it seems pretty straightforward. I'm not gonna get to the point where I print the 6 decimal places just yet. What I'm gonna do is, because I don't know, I have to look it up. What I'm gonna do is, say decimal places, Python, see which genius of the flow has solved this question for us. Okay, we can use the round function. We can do string formatting, f strings over Python 3.6, and we can use the format method. Decimal model for high precision. Okay, so this is where we are going to. Where we are going to really be interested in decimal model for high precision, because that's the problem. The problem starts with that. And we can see here in all the outputs how obviously they're used for simple reasons. My wife is calling me. Come on, babe. Anyways, alright, well, that's part of the process. Another reason to work hard and give my family a better life. Anyways, decimal model high precision. Okay, I'm assuming we can take these formatting options that, you know, the round, instead of saying 2, we can say 6. Instead of saying format to 2F, we could say 6F. But since the problem actually used the word S, specifically high precision, then Python provides the decimal module. This module supports arbitrary precision and is specifically used for financial applications, yada yada. So I gotta import, we have to import a model and set the decimal places I want to use, get the number, and then print that number. Okay, so it's not necessary for most everyday applications, as the built-in flow type provides sufficient precision. However, when working with financial or scientific, okay. So we're gonna try, what we're gonna do, just to test the extent of the problem, I'm gonna try using the round function. Since I don't have to import any other module, I'm just gonna use like a built-in model, right? And use, in this case, since we're printing, we can use string formatting, because I can see here that number 3.4 pop 2F format number. I can see here, I'm assuming, I'm not really I'm not really familiar with this, but I'm assuming that this is gonna export or print or return, whatever, a floating point, right? A good question to ask in this point would be if we have to return any particular type. Like, do we have to return a floating point number? Do we have to can we return the number in a string format or string type? But it says print the ratios of positive, negative, and arrays should be printed on a separate line with 6 digits after the decimal. Should not return any values. So in Python, not all strings always are represented with a quotation at the moment of printing. I could be wrong in this, but as far as I remember, you can print strings and not necessarily have the quote marks at the beginning and end. But let's assume, for the purpose of using numbers and, you know, we're using integers as inputs, we're gonna return floating points. So going back to, where is it? Going back to this, we're gonna use one of these functions, right? So we will round the final number, or I'll use format. So I'm gonna go back to here and code the little logic we just set. So what do we need first? We need to have 3 counters. So I'm gonna say positive count. Let's not be lazy. Positive count is gonna be equal to 0. 0 count is gonna be equal to 0. And negative count is going to be equal to 0. So, Yeah, I know I assigned it and never use it. I haven't finished the code. Jesus. Can I finish before you guys start showing me errors? Whew, sorry. I'm gonna say for. Okay, so before I start like typing code here for simple as this looks, I have a thread here, loose thread in my shirt, and I'm just gonna go ahead and boop boop. Thank you, shirt. Anyways, we are talking about we are going to. So edge cases, right? I haven't think about any edge cases. Like what happened if the list is it's empty or we print. But I don't think we normally look in constraints for that. Constraints. You know, we're always gonna have a list of integers, so we don't have to think about the list being empty. This thread keeps bothering me, but I'm gonna just leave it there for now. I'm gonna rip my whole shirt off here. So yeah, we don't have to manage any edge cases, particularly because we don't have, we're always gonna have, based on the constraints, we're always gonna have an array of integers. Any other edge cases where the number is greater than that? No. So we're pretty straightforward. I think they're just looking for us to have a simple, like, this is a very easy problem. If you guys look, like, I'm in the warm-up area for algorithms. I'm studying for to land a job in tech and, landing an interview, but I'm in the very beginning. It's actually day one for me on recording this set of problems and stuff. So I was doing this back in we're in 2024 right now. I was doing this we're actually in, gonna give you exact date, September, because I hate when people are talking like, oh, I was doing this last year, blah blah, but then you watch the video 5 years later, you don't know like where that person was or the technology that was around at that time. But anyways, yeah, September 29, 2024. I started learning Python 2021. I've been in a path of learning Python and Swift and other technologies. I have a few projects on GitHub, simple things. But yeah, my job is to land an actual job in the tech industry. So yeah, we're just trying to put some content out there and keep people looking at the effort we make every day, and it's kind of fun too. But anyways, going back to this, Jesus, we're gonna iterate over every number in the range of, well, we don't have to use range where we have an array, so an array is an iterable. So we're gonna say for every number in the array, if the number is greater than 0, we can say that it's a positive number, so we are going to add it to our positive count, same positive count plus equal 1. If the number then is not greater than 0, means that the number could be less than 0. So let's say if n is less than 0, then we're going to update our negative count and say negative count plus equal 1. And then if it's not greater than 0 or less than 0, then it must be 0, right? So else 0 count plus equal 1. So we already have our counter. That's the first part. So once we have our counter updated, Jesus. For the sake of simplicity, can we divide right away? You know, you update the counter at the end, you have all your numbers. I'm assuming you can make this way simpler, but let's go for the iterative approach, right? So we're saying positive count divided by the length. We're going to assign this to a variable. We're going to continue after a little break, completing the function. So we have the counters, positive, 0, and negative. We have our conditionals that says if it's greater than 0, positive, no, negative, else 0. We update those counters, and then we say positive radio. Then we have negative ratio. And it's going to be equal to the negative count divided by the length of the array. We're going to copy that because it's going to be the same thing for our 0 ratio. That's going to be 0 count. Then after that, we are going to print, once we have the variables, we already know we're printing 3 different values, so I'm just going to go ahead and do this. We said we were going to use the round function, so we're going to try with the round function first and see how that works. If it doesn't work with the round function, then we're going to go and try a different model. The reason I want to go with one of these, that we should be good with it, is because I don't want to import or anything. Again, the reason why I'm doing this is interview purposes, so unless specified by the interviewer, I'm not going to be allowed to use any outside libraries, right? So I want to keep things as neat as possible. It is very possible that I would have to implement this myself too in an interview setting, with like the round function, which that's going to be my next task after finishing this this problem, because that's the main point, right? We want to learn as much as we can and try to do things ourselves, right? Depend on ourselves and be resourceful, right? So we're going to do it the round function. I don't think we have any problem with that in an interview, but in the case, that's a follow-up question. It could be a follow-up question. How would you implement that yourself? So I want to be able to know that. But for now, we're going to say, you know, we're going to print, we're going to round a number. You know, it says round a number to a given precision. So the first number is going to be positive ratio. We're going to round it to a 6th decimal. I believe that's the way that, yeah, that's the second argument. I don't know why I assumed that. But it's going to be the same thing here. We're going to round. And there are going to be, not negative count, negative ratio. There are going to be different ways to do this. Like everything in code, there are always going to be different ways to do what you are doing. 0 ratio. But this is going to be the long way, I assume, right? This is going to be the iterative way where we go step by step. I'm 100% sure I can come back a second time to this and try to use a list comprehension, solve it through a list comprehension. I can sit there and think about any other data structure that I could use to simplify the process, right? For right now, we're trying to go with this simple approach and brute force, right? This is literally brute force in this thing. Let's see if it works. Let's move our camera up here. We have everything we need. We have the counters to 0. Our conditionals. We got our last numbers, and then we have our results. So we're going to run our code first, see if it passes the first 2 test cases. So we see we pass both, right? We have 1, 2, and 3, minus 1, minus 2, minus 3, 0, 0. My output, oh, okay. I see here something. Round is very particular, as I've seen. So my output was 0.5, which is correct here, but it doesn't have the 6 decimal numbers, and I'm specifying it here. I want 6 decimal places. Now, for some reason, it's not in this particular case, and in this particular case, it's different too. Like, it's passing the test because they said it here, you know, like they're acceptable, 10 to the 4, 10 to the minus 4. However, they're asking to have 6 decimal places. So even though we're passing the test, I can't consider that I'm solving the problem the way they're asking for, because my output is different, right? If we were using precision, then my code is wrong. So, you know, honestly, they can make this a little harder and force you to actually, you know, be precise with your output. I don't want to submit it because now I want to actually get the results I have to. So I see that for some numbers I'm getting the 6 decimal places, like here and here, which we're talking about. Let's just quick analyze. If we have 1 and 2 out of 6, so that would be our 0.33, or 0 would be our 0.1, and the 3 positives on a 6 would be the 0.5. 0.3, 0.5. I said something wrong there, but is it if it's after a certain number? No, because here's 0.2, 3, and 3. Here's 0.3. So it's very random, huh? We should read a little bit about that, the round function. Round the number, so we have this number. So the round function, as I see, is it cuts down. I mean, it rounds, right? But it doesn't round up. It rounds down, if that makes sense. I have a meme just came to my head. I don't know if you guys have seen the video. That it's very, I mean, of course you guys have seen it. It's from here, but it's like it goes down. It's like the guy on the boat and the other guy on the other side is like singing, and then I'll have to look it up now. I have to look it up. I talk about it. I have to look it up now. Should we make this flexible and look it up? Should we show the video to people here? I mean, I'm not trying to be an entertainer by any means, but man, I made a reference of something that I should now show. So people probably got it, but for the ones that didn't get it, it goes down. Mean. This one. Don't make me play it. I'm pretty sure you've seen this video. I won't play it now, but you've seen this video. If you haven't, just go see. Just go watch it. Just go watch it. Trust me. So this is what I mean here. It goes down. Same thing here. It's rounding down to the 2 decimal places. So it looks like we might need decimal. I'm just gonna say round function, round up, Python. Round up a number. With Python, you can round up a number to its nearest integer, 3.7. Not necessarily that. Round to 2 decimal places. Round. Nearest integer. Oh, function without specifying decimal places. The round function without specifying these own places will round to the nearest. Okay, if I don't specify, but I did specify 6 in all of my cases. Huh. See, this is the actual problem, guys. I just hope we're recording audio. I just realized. Yeah, I think we are. Anyways, I need to eat. Match seal, yeah, I've heard of that one. Round with decimal places, round to a specific number of decimal places. I'm gonna say round precision Python. We shift round precision, including built-in round. Round is a number to specific number. We already know that doesn't work, man. Math seal, math floor, rounds up on the nearest. I've played with those. Decimal. We're gonna have to use the decimal model, right? String formatting, use this model operator or format to specify precision. I just thought about something. If we divide by the length of the array, which is 6, but if we do this, divide by the length of the array times 0.6. 0.6. No. Let's do something quick here. Position count. So I'm gonna say that I have 2 divided by 6, and even my search bar times 0.6. That is gonna count to that decimal place. Yeah. So it's gonna cut to the decimal place. How do I get the precision without using the model, guys? That's the whole point of this. I don't wanna import any model. What? Okay. So if we use the string formatting instead of the rounding function, so we say we go here and say print 6F. I believe that was the syntax. Nope. It's going to be mod.6f. So modulo.6f and modulo.6f, and then we can do format, or we can just mod the ratio. So we're just going to mod the ratio. No extra spaces. And we're going to take this 6 out of here because we don't need it anymore. And we are going to go ahead and do the same thing. Do the same thing, do the same thing, do the same thing, do the same thing. Let's hope this works, because this is actually the way to solve it. Positive ratio. ratio. And 0 ratio. Print. Okay. And print model. Oh, Jesus. Okay. Man, oh man. Yeah, I don't like to copy code because what am I doing? It's model dot f. Yeah, that's what I did. I think model dot 6. Yeah, that should work. That should work. It does work. Beautiful. Let's go. Now we have, guys. Now we solved the problem. Now we have. Wait a second. We have 3 and 3. Yes. Now we can say we solved this problem because now we have the 6 decimal places that the function's asking. And you'll be like, oh, this took you 45 minutes, blah, blah, blah. Yeah, everyone, it's in their own path and their own process. The actual motivation I have, it's that I actually went through the process and cleared out everything and got the actual result. I could have submitted the code. It probably would have failed the first time because it didn't have all the decimal places, but they said 10 to the -4 are acceptable, so it maybe would have worked. But we want to make sure that we had all the requirements in place. So, 10 p.m. night time. I might solve another problem after I have some food. It's really late for me to eat, but I'm gonna eat anyways. But I'm satisfied that we solved this problem together, whoever is on the other side of the screen. And yeah, let's go ahead and submit the code because we might have some problems. And I'm here like, but I think we're good. For the most part, I think we are good. Patiently waiting. Congratulations. Yay. Oh.
I love you, Taylor. Te amo mi amor. And rude.
Hopefully, I have the noise cancellation. You guys didn't hear that. That's a little setting I have. If you do, that's a little setting I have for my wife before nighttime. But anyways, we solved this thing. Very, 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 very good. Very good. I feel proud of myself, man. This is the little drawing I did in the other side. If you guys didn't see it, right? This is how we actually determined how we were gonna do that. That's very useful most times. And yeah, we solved this problem. Thank you for being here. Let's move on to the next problem.